Let's talk some more today about factoring. We're going to be factoring quadratic trinomials, which we did a little bit in our last video. We'll do it by grouping, we'll do special cases, and then we'll do some solving with it. So remember factoring by grouping. Factoring by grouping is when you have four terms, and you split those four terms into two groups, and pull the greatest common factor out of those. So I'm going to slash this in half right here, and I'm very careful to keep this negative with that 6x over there. Out of the left half, I can pull out an x. Out of the right half, I can pull out a negative 6. And since these two factors are the same, these two things combine to be one factor, and then x plus 2 is the other. So that's factoring by grouping. Now the thing is, this is really a quadratic trinomial. Trinomial means three terms. It has four terms, but it's really a quadratic trinomial because we could write it as x squared minus 4x minus 12. We could combine these two. So what this tells us is that we can factor trinomials if we can make them into four-termed expressions. So we're going to use factoring by grouping and turn a three-termed expression into a four-termed expression. The key is splitting up this b term, right? Like this b term, negative 4x, was split into plus 2 and minus 6x. So quadratics come in the form ax squared plus bx plus c, where a and b are coefficients and c is a constant value. So in this expression down here, we have an a value of 2, a b value of negative 6, and a c value of negative 8. Off here on the side, I've written out the steps for factoring by grouping. I'm going to follow these steps. It's fairly straightforward, actually. It's a lot of steps, kind of, but they don't take long to do. The first step is multiply a times c. A times c is 2 times negative 8, which is negative 16. I'm going to next write out the factors of negative 16. I recommend you do this in a really organized fashion, like 16 divided by 1, 16 divided by 2, 16 divided by 4, and then don't forget that if you have negative 8 and 2, you also have negative 2 and 8. If you have negative 16 and 1, you also have negative 1 and 16. Okay, that was step 2, write out the factors. Step 3 is to find the pair of factors that add to b. I want to find something that adds up to negative 6. Negative 8 and 2 add up to negative 6. So negative 8 and 2 are the two values I'm going to get that I split this b term. So bx is going to split into the two factors that I just got. What that means is this negative 6x is going to become negative 8x plus 2x. The minus 8 and the 2x squared are still there, and I've now made a four-termed expression out of this three-termed expression. And it's a very special four-termed expression because it can factor. Out of the left half here, I can pull out a 2x, leaving me with x minus 4. Out of the right half, I can just pull out a 2, leaving me with x minus 4. These two things will combine into one bubble, one factor, and these two combine into the other. So we get 2x plus 2x minus 4. Now, I'm all of a sudden feeling kind of silly about this. I should have picked a different problem because this could have started and should have started by me pulling out a GCF. This problem has a greatest common factor of 2. I should have started by pulling that out. We'll talk about that more in a future video. So this is factoring by grouping. You follow these steps, you factor by grouping. It's fairly straightforward. Let's do another example. I have x squared minus 5x plus 4. Well, my a term is 1, my b term is negative 5, my c term is 4. I multiply a and c. 1 times 4 is 4, and I write out the factors of 4, and there aren't that many. Don't forget negatives. Negatives count as factors here. I want to find the pair of factors that adds up to negative 5, because negative 5 is my b term, and that's these two right here. So I'm going to split this up into x squared minus 4x minus 1x plus 4. You can flip the order of these. It doesn't matter which order these two terms come in. It'll still factor just fine. So either way you set this up is going to be okay. Now, on the left side of this, I can factor out an x, and I'm left with x minus 4. On the right side, all I can pull out is a negative 1. But I do pull out the negative 1. And that again leaves me with x minus 4. So I combine the x minus 1 and the x minus 4. And boom, we factored. Remember, the way you check factoring is you go back and you do the redistribution again. X times x is x squared. X times negative 4 is negative 4x. Negative 1 times x is negative x. Negative 1 times negative 4 is positive 4. This becomes x squared minus 5x plus 4, which is what we started with. So the check is solid. Okay, that's factoring by grouping. It will work every time. If a problem cannot be factored, you wouldn't be able to find a pair of factors that add up to the b term like you need. So it'll tell you pretty early, right here at step 3. If step 3 is impossible, then you'll know the problem can't be factored, like x squared plus x plus 7. That's a problem that can't be factored, and the grouping process will break down at step 3. There's some faster ways to factor, though. Those are called special cases. Special cases we talked about with multiplying earlier in the year. You know, we know that a plus b squared equals a squared plus 2ab plus b squared. Like if I have x plus 3 squared, that is not x squared plus 9. It's x squared plus 6x plus 9, because you have to do x plus 3 times x plus 3, and you have to do your foiling. So these are the 3 special products that we worked on last chapter. A plus b squared, a minus b squared, and then the difference of squares. A plus b times a minus b is a squared minus b squared. For example, like x plus 5 times x minus 5 is x squared minus 25. That's an example of a difference of squares. Well, factoring is just doing that process backwards. If I have a perfect square and another perfect square and they're being subtracted, this is called a difference of squares, and I know that can factor into the square roots, right? The square root of 16 is 4, so x plus 4 and x minus 4. If you have 2 perfect squares that are subtracting each other, you square root them and put a minus in between them. And there you have your difference of squares. Okay, that's a special case that you can factor very, very quickly, and it's fairly common to have a difference of squares. It's something that pops up pretty frequently. So another example is if I have something like x squared plus 10x plus 25. Well, here's what I'm looking for. If my c term is a perfect square, and my a term is a perfect square, and my b term is even, 2, 4, 6, 8, 10, 12, something like that. If these 3 things happen, my a term and my c term are perfect squares, my b term is even, then I think it's fairly likely that this factors into x plus 5 times x plus 5. So I do it and I check it. You have to check it because that won't always be the case. Okay? But I get x squared plus 5x plus 5x plus 25, which is x squared plus 10x plus 25. So yes, it checks. So if your a term is a perfect square, and your b and your c term is a perfect square, and your b term is even, then it's very likely, not guaranteed, but quite likely that you have a special case. This would be x minus 10 times x minus 10, which we would just write as x minus 10 squared. Like up here, we would actually write this as x plus 5 squared because that's prettier. And it's actually easier to work with. If your a term is if your a term and your c terms are squares, and your b term is even, positive or negative, but even, it can probably factor by this special case where you square root this and make them both minus or plus, depending on if it's subtracting or adding the b term. Okay, finally, the main reason, not the main reason, one major reason that we solve, that we, sorry. Okay, finally. Usually I edit these videos, but I'm not going to because I'm tired and out of time. So you just have to live with me clearing my throat like that. Sorry. A major reason that we factor is so we can solve quadratics. It's not the only reason, but it's a major reason. Now, solve means you have an equation. So far, we haven't had equations, right? Like, these weren't equations. These are just expressions that we were factoring. We were rewriting in different forms. This is an equation made of 2 expressions. We're going to take the quadratic expression and factor it, and then we can use the factors to solve. See, we're trying to find the values of x that we could plug in. Like, what numbers could we plug in for x so that this comes out to 0? Well, if you try to solve this by regular algebra methods where you, like, just try to get the x by itself, it doesn't go very well because you have 2 x's. Like, if you divide everything by x, you get x plus 8 equals negative 7 over x. And then maybe you subtract the 8 from both sides. But you have an x here and an x here, and it's not going to go well because you have multiple x's. But one option is to factor. This can factor into x plus 7 times x plus 1. Okay, that's how that factors. The key is that it's equal to 0. If something is equal to 0, we can typically apply what's called the zero product property, which basically states if two things are multiplying to 0, one of them must be 0. And possibly they both are, but at least one of them has to be 0. See, if we have 3 times something equals 0, we know that something is 0. And if we have something times something equals 0, we know that one of those something is zeros. But that's only true with 0. If we have something times something equals 4, it could be 2 and 2, it could be 4 and 1, it could be 8 and a half. There's an infinite number of things, an infinite number of pairs that can multiply to 4. But if you're multiplying to 0, we know that one of them must be 0. That's called the zero product property. So basically, when I have this equation, x plus 7 times x plus 1 equals 0, I know that either x plus 7 equals 0 or that x plus 1 equals 0. So I solve both. These are my solutions. We could say x is the set negative 7, negative 1. You factor, and then once you've factored, you solve your two equations. You solve your two factors. You set the factors equal to 0, and you solve them. So I'm going to factor this one. I'm not totally sure how this factors. You might be somebody who likes to guess and check, where you put a 4 here and a 3 here and a minus here and a plus here, and there, that's how it factors. If you're a guess and check guy, keep doing that. But if you're not a guess and check guy or gal, you can always multiply a times c and do grouping. A times c is negative 24. So the factors of negative 24, there's a decent amount of them, are these. This pair adds to negative 5. So I'm doing the grouping steps right now. This becomes 2x squared minus 8x plus 3x minus 12 equals 0. You cut it in half. The left side has a 2x. The right side has a 3. So it's 2x plus 3 times x minus 4. And this is all equal to 0. Okay, I still have the equation equal to 0. Well, if it's equal to 0, I take my parentheses, I take my factors, and I set each of them individually equal to 0, because I know that one of them is going to be 0. So I subtract 3 from both sides and divide by 2, and add 4 to both sides. My solutions are negative 3 over 2 and 4. Okay, so that's how you solve by factoring. You must have an equation to be able to solve by factoring. And to have an equation means you have an equals sign somewhere. Otherwise, you don't solve. You can factor, which is kind of a different way to rearrange an expression to make it more useful or to understand different components of it. Okay, so to recap, we can factor quadratic trinomials by turning them into quadnomials and grouping. Special products, like a plus b times a minus b, which comes from difference of squares, are very common and have simple shortcuts. Some quadratics, but not all, some quadratics can be solved by factoring. And you can only solve equations, meaning there's an equal sign present. You can't solve if you don't have an equation. That's all for today. Thanks for watching. See you next time.